Hello, Floridians. Hope the DECA trip is going well for you guys. Today we talked about two more chi-squared tests. The test for homogeneity, which is similar to a 2-prop z test, and also the chi-squared test of independence, where we look at a matrix of values or a table and see if that is consistent with what we were expecting. Okay. So the chi-squared test of homogeneity has the same assumptions as what we talked about yesterday with the goodness of fit test. You need categorical data, random selection, independent samples, and the expected numbers in each cell has to be greater than or equal to 5. Okay, now the goal of this test is to answer the following question. Are these distributions about the same? Okay, again, meaning consistent with each other. So below, we have the data from two teachers who teach the same course. So the null hypothesis is the distribution of grades between the two teachers is consistent, meaning close enough. Now, if we reject that, that means they are not consistent, which means they are not close enough. All right, so I've got my data in there, okay? And we do this test the same way we did yesterday's, the goodness of fit test. You just got to make sure that you plug in the correct number. And remember, the degrees of freedom, the DF, is k minus 1, the number of categorical data categories minus 1. All right, so we get a p-value of 0.004, okay? So I go back over here. Alright, so my p-value is 0.004. We have no specified alpha level, but 0.004 is lower than any reasonable alpha level, so we are going to reject the null hypothesis. Therefore, we can conclude the two teachers' grade distribution is not consistent with each other. And let's pretend that I punctuated that appropriately. There we go. Okay? Chi-squared test of homogeneity. Now, Mr. Cohen was at his kid's soccer practice on Saturday morning, and he thought to himself, there appear to be a lot fewer kids than last week. So you know exactly what I did. Okay? I counted. I knew how many kids there were last week, and I took out the Wabbit Emu app on my phone, and I did a little chi-squared test. Okay? So the data I have right over here, that's my L3 and my L4. So I ran a little chi-squared test. All right, now let's suppose I select the wrong test. You'll notice if I go to hit L3, it won't let me. So the calculators are fairly idiot-proof, which is nice. Okay? So the goodness of fit test, L3, L4, two categories, DF1, and same thing. Okay? So here you'll see we get a p-value of 0.3, which means we fail to reject. It doesn't really matter, the alpha level. So since we failed to reject this statement, again, the distribution of kids is consistent between the 2 weeks. So we cannot conclude that there were significantly fewer kids from the previous week, even though it went from 46 to 39, and every group, both of them, both two groups dropped in attendance. Okay? Hopefully there's no questions, because you can ask questions, but if you need to review, you can rewind and pause and all that other stuff. All right, so we've got this chi-squared test for independence, and this has the same assumptions as the previous ones. Only now we're dealing with much bigger tables of data. Okay? All right, the goal of this test is to see, is the observed distribution about what we expected? Okay? So it's a combination between the goodness of fit test and the homogeneity test. Okay? Now, basically, so what we're saying is, are the two variables independent of each other? All right? Let's take a look at the first one, or the fifth one if you're keeping track. Medical researchers enlisted 90 subjects for an experiment comparing treatments for depressions, the subjects were randomly divided into 3 groups and given pills to take for a period of 3 months. Unknown to them, one group received the placebo, the second group received the natural remedy, St. John's wort, and the third group received the prescription drug Posrex. After 6 months, psychologists and physicians who did not know which treatment each person had received evaluated the subjects to see if the depression had returned. Okay, so our null and alternative hypotheses are pretty easy. The treatment and diagnosis of depression are independent of each other, which basically means if we find that out, that means whatever we're talking about here didn't have an effect on the subjects, which means all the groups are about the same. Okay? The alternative to that is that they're not independent and that the treatment actually did have an effect. But before we get going on this, okay, the whole situation, okay, we've got our 90 subjects, okay, and I used a brown color because they're depressed, okay. 30 of them were given a placebo, okay. Another 30 were given the natural remedy, and the third 30 were given a prescription drug. And the idea is to afterwards compare. Okay? And what you don't see in here is my random assignment. So this is a decent little experimental design. All right, now, I filled out some information for us here. So 60 of the people who returned showed signs of depression, whereas 30 didn't. So 2/3 of all people in this study had the depression return, whereas 1/3 showed no signs of depression. All right, and again, we knew there were 30 of each in this study. Now, here's the part where we have to figure out what we expected. Since 2/3 of the people in this study had depression return, we would expect 2/3 of the placebo to have depression and the other 1/3 not. Same thing with St. John's warts. So 20 and 10. So again, we expect 20 of each of the people or each of the subjects in each group to have the depression return and 10 not. Again, that's the whole idea of independent. We're expecting the same thing out of all of them, meaning the treatments had no effect. Okay? Well, that's the idea. Again, if we can reject, then we see that there was some sort of effect. Okay? And it's not specified here, but since we're talking about medical stuff, let's test this at the alpha equals 0.01 level. All right. So pick up my calculator. And again, here you have to put them in as a matrix since we have multiple rows and multiple columns. Okay? So I go to the matrix menu. Again, I have a 2x3 matrix. Remember, it's observed minus expected, but your calculator will ask you for those anyway. Again, all I did was type in the numbers from the original table: 24, 22, 14, 6, 8, and 16. Okay? And again, group 2, we're expecting each of the groups to be the same 20 and 10. Okay? So I'm going to do my chi-squared test. Again, if you choose the goodness of fit test, it won't let you choose matrices. So we do this one. All right, now my observed data was in matrix C, and my expected data is in matrix D. And here we see that we have a p-value of 0.015. Okay, so p-value equals 0.015. Okay, now that is really close to the 0.01 that we were testing. However, we're still going to fail to reject. Okay. Okay. To be totally honest with you, if I were one of the experimenters, I would say that the p-value is so close to the alpha value that even though we fail to reject, there's enough information for us to, research more. Okay? So technically, in this instance, okay, the treatment and diagnosis of depression are independent of each other. Okay? All right, we've got this next one here, which we're not going to have enough time to do today. A national survey was conducted to obtain information on the number of vacations a year U.S. adults over the age of 18 take each year. So we've got our random sample of 1,772 adults, which gave us this information below, and we're going to test this at the 0.05 level here. So can we determine the marital status and the number of vacations are associated? All right, so we've got our null and alternative hypotheses. They are independent or they're not. All right, now here's where things get a little bit tricky, but what I'm going to do first is I am going to run through the assumptions and conditions. Do we have categorical data? Yes. Again, they either take no vacations, 1 to 2, or 3 or more. Okay. Do we have a random sample? Yes, that's stated in the problem above. Independent. Okay. What single people do and married people do, widowed, divorced, all of these different groups are totally independent of each other, and the expected numbers in cells are sufficiently large. Okay, so now, as you can see, we had 1,772 people partake in the study. 354 of them were single, which is approximately 20%. 1,174 were married, which is 66.2%. 143 widowed, that's 8%, and 102 out of the 1,772, that's 5.8%, were divorced. Okay? The red numbers indicate the expectation. So we're expecting 20% of the people who took no vacations were going to be single. That is 118. Okay? 66.2% of the 590 people who took no vacations are supposed to be married. That's 391. 47, 34. So I did that for all of these. So again, 20% of the people taking 1 to 2 vacations, that's 191 for single. So I plugged in all of my numbers into my matrices, and here you can see, here's the observed, okay? Here's my expected, and those are the exact numbers, whereas close enough. Okay, so now stat, test, chi-squared test. Okay, and here we get scientific notation in our p-value. So since our p-value is 3.925 times 10 to the negative 18, comma, we reject the null hypothesis. Okay, so what we're saying is that marital status and the number of vacations per year are not independent of each other. Okay, meaning there's some sort of a causal relationship, but we're not worried about what causes what just yet. Okay, good luck. If you need to rewatch some stuff, go for it. I'll see you guys in class when I see you in class. Peace out.